This is where we are continuing the solving problems from Project Euler. And last time we have solved problem 12, and we want to continue. Today we'll probably solve one or two problems. I'm not really sure how many. So let's take a look at problem 13, maybe problem 14. I don't know what it is, but yeah. So let's look at problem 13 first, see how long it takes to solve. Incidentally, I had solved it earlier, some time ago, and that is the answer. But I had solved it in another programming language called Haskell, and in Haskell it's pretty easy to solve. And the reason is because Haskell has something called arbitrary precision mathematics, which means that you can just plug in a large number like that, and it will consider that to be it will be able to handle a large number like this. But in most other programming languages, the large numbers are the large numbers are limited by the word size, and as a result something as large as a 50-digit number will only be approximated, so you won't be able to find the first 10-digit number very easily. So you have to write some code for doing that. Let me try and explain what the problem is. So let's first call this problem 13. Okay, and let's just copy paste the problem. The problem is problem 13, and we need a large sum. So that's the problem that we're trying to solve. So we have worked out the first 10 digits of the sum of the following 150-digit numbers. So let's copy this first. That's a lot of numbers, and that looks like that's an incredibly large number of numbers. Wow. Do I? Huh. Okay. Okay. Yeah. So that's a very large number of numbers. Okay, and we have to find the first 10 digits. And so if you have a number, an integer number, this would be the first digit, this would be the last digit. Okay, the first 10 digits would be this 4 5 6 7 8 9 10 for this number, but we have to add all of these numbers together and then find out what the largest digit happens to be. What is this? Okay, all right. So how do we do that? Okay, so what is the problem? Let's say in Python you can write a number that looks like that: 1 2 3 4 5, and that is an integer number represented by the 5 digits 1 2 3 4 5. And you can represent a large number like that as a string, but that's not a number. It's just a string. A number would be something like that, and if you wait, how is this possible? Python. Okay, I didn't know it was possible for Python to do arbitrary precision mathematics. Let's give it a test. Okay, this is uncharted territory for me. Okay. Let's take a look at this. Copy. Let me see if this is actually possible. Okay, this is amazing. If this can be done in Python, then it is really amazing. So numbers is that, and I will do that. Okay, so we have a bunch of strings, and if you split it, numbers equals numbers dot split on /n on the new line. I think there is a blank over here which we need to get rid of. Let's make sure there is no blank at the end. There's no blank at the end, so I would say numbers is 1 onward. So let's do that, and let's do that, and let us see if we can just convert it into a list of ints. Int n for n in numbers, and let's see what we get. Okay, numbers. Okay, I am surprised that Python is able to handle this. Okay, all right, let's see. 1 2 3 4 5 6. Let's convert it into a string that looks like that, and let's take the first 10 numbers. So is it 1 2 3 4 5 6 7 8 9 10? If this is the answer, I would be really surprised. If Python can do this. Wait, 5537. Yeah, this is not the right answer. The answer is 55. Well, it came close. But it's not the real number. Shame. Let's make sure that we have done stuff correctly. Okay. Yeah, it's not correct. 550. Yeah, so Python actually cannot handle very large numbers. Okay, so let's get back to the problem. Okay, so we have to create a list of numbers. Okay, numbers. We'll call it number string. So if we mess up, we can always equals numbers str dot split. Okay, for n in that, we want to create a list map int n, and let's look at what this gives us. Numbers. let's look at the first one. Okay, it gives us a list 463 blah blah blah. With numbers. Okay. Numbers string. It starts with 463. Ah, I hadn't copied the first line properly. Whose fault is that? Huh? It is mine. Okay, so if I do have this, I hadn't copied it over here. Okay. Okay. Okay, and if I have, okay, let me, okay, so I had messed up. Let me try that thing one more time, like the thing that I was trying to do previously. Int n for n in numbers str. Okay. And let's just print this. Dot split slash n. We have this number, we have this number, and so on. 4, 6, blah blah blah. The last one, just to make sure, is 5350, all of that stuff. Let me see if we sum this. Sum none. Are you kidding me? 55 str, and we take the first 10. 553737 553737 6230. Wow. Wow. I am floored. I am floored by Python. I did not know Python had arbitrary precision mathematics. Okay, I learned something new today about Python. Okay, well, we have solved this. Let me stop this. Okay, maybe we can solve one more problem, because this seemed like really too easy, even in Python. I thought we had to add things one by one, but hey. Okay, so problem 13 solved. Okay, problem 14. I haven't solved this before, so this is interesting. What is this? We'll call this problem 14. 14, all right, and let's name it. Problem 14, and it's called the longest collapse. I don't know whether I'm pronouncing that properly. It's collapse, longest collapse sequence. Okay. Ta-da-da. Okay, so Okay, let's try and figure out what this is. The following iterative sequence is defined for the set of positive integers. Okay. N will become n by 2 if n is even, and n will become 3 times n plus 1 if n is odd. Okay, it is what it is. Use the rule above, and using the rule above and starting with 13, we generate the following sequence: 13, 14, 20, 10, 5. Okay, so 13 is odd, so 13 times 3 is 39, plus 1 is 40, so it goes to 40. This is even. We divide by 2, it goes to 20. If we divide by 10, it goes to 5. 5 is an odd number, so 5 times 3 is 15, plus 1 16. It gets divided by 8, 2 to 8, 4 to 1. All right. Okay, so that's the sequence. Let's see if we can create a function that creates that sequence. So define collapse sequence. I won't even try to spell that. It's given a number n. It is going to return the sequence, and it is going to return the number for the length of the sequence. So given n, sequence is that it starts with n, and while n is not equal to 1, okay, we are supposed to do this. If n 0, okay, so if it's even, n equals n plus, with n equals n by 2. Else n equals 3 times n plus 1. So that's the collapse sequence. We need to add this to the sequence. Stand n, like that. And over here, we want to return the sequence, and we want to return n, the length of the sequence. Okay, so we can I think create the collapse sequence. Copy that, and let's find the collapse sequence for 13. Int is not an object. What the hell are we talking about? Sequence.extend. Sequence.extend. Oh, okay. Use the wrong function over here. Okay, now we are in business. So let's make sure we have the right sequence. 13, 40, 20, 10, 5, 16, 8, 4, 2, 1, and contains 10 terms, so we get 10. Okay, that's good. Okay, although it has not been proved yet, that's called the collapse problem. Do you guys know how to call? Is this called collapse? I don't know. Okay, never mind. If you know what it is called, just let me know. But anyway, it is thought that all starting numbers finish at 1. Okay. Which starting number under 1 million produces the longest chain? Under 1 million. So we have to find values for everything. Right. Okay. So basically let's try one thing. 2 to, let's say, 20. Okay. Sequence and n equals C sequence I print n print I. Let's create an F string over here. F string, that's I, and we want to print n, and we want to print the sequence. I think we can do some optimization over here. What optimization you say? Okay, so let's think about it. If we are in this point 5, we see that we have already calculated the collapse sequence of 5 over here. So we don't actually need to calculate this thing at all. Alright, so the moment we go to 3, we have calculated the collapse sequence for 3. We have calculated the collapse sequence for 10, 5, 16, 8, 4, 2, 1. We have calculated the collapse sequence for all of that, and we should be able to save all of that in memory and then not calculate from a certain point on. So that's something that we have to use to optimize the code. So what we can do is, let us do one thing. Let us let's try something else. Previous sequences is that. So we just have the previous sequences, and we have to update this. So let's create, we'll call this old. Okay, and we'll create a new version of this, like so. That is going to take n, and that is also going to take the previous sequence, and it is going to assume that it has not seen n before. Okay, that's a fairly general enough thing to make, because I will not give it something that it might have. So if n in previous sequence, okay, just return previous sequence. Like that. Okay, just return that. Don't worry about it. Otherwise, we have to start thinking about this. Okay, so we create our sequence, we add n to it, and then we get in here. All right, we have a new n over here. Okay, now the question is, are we going to add n to this thing? Now this new n might already be present in previous sequence. So if n in previous sequence, okay, then you just return whatever we have created so far, which happens to be sequence, plus, in this case we are not returning the length of the sequence, we are just returning the sequence plus sequence n, because we have already seen that. This should be a much better algorithm. Oh wait, I should not be calling this old, I should be calling this that, and I should be calling this old. Okay, so now if we do this, one missing parameter, which is previous sequence. So we already have something called previous sequence, and we say, okay, we don't know, we don't have this. Oh, what the hell just happened? Understand. Previous sequence is a dictionary. Okay. If n in previous sequence, we should return previous sequence n, else what we should do is we should say we should not return this, we should say previous sequence plus equals like that. and there is no update of previous. So we are going to return the result as well as we're going to return previous sequence because we want to update previous sequence. Okay. Now we want to update sequences that we want to say previous we have to keep an original n equals n. Okay, and then the rest of the things are fine. Like this, we say we add an original, okay, an original to be equal to that sequence. Otherwise, and return, so we don't have to calculate everything again, return the sequence as well as the, okay. If that does not happen and we come over here, then we have to again do that. So we have actually created a sequence, an entire sequence like that, and we want to return the sequence and we want to return the previous sequence like that. I think that's what we want, and we see that we provide 13 and it returns 13 and says okay. That's not true. So sequence is n. Okay, if n is even, then it creates a new n, which is fine. If n in previous sequence, so we have a new n, and if it is in previous sequence, it will add previous whatever the value for previous sequence was to itself. It will say previous sequence, this is equal to sequence, and it will return the sequence and the previous sequence. And otherwise it comes all the way down over here and says previous sequence and original equals sequence. I am surprised that this doesn't work. Okay. I'm technically supposed to use a profiler over here, but so it definitely doesn't do this. We want to print that we are inside, and at this point we are n. Okay, so that's the current number. And let me see, n, if n in previous sequence, okay, we want to print n over here, and over here we want to print previous sequence over here, and check if n is in previous sequence. Then we should also print sequence. Okay, something is not getting updated. Okay, so it's going through the motion, and then this sequence is not getting updated. No wonder. Okay, otherwise so that's the result, and we get back the previous sequence of this. Okay, there are, I think, further optimizations we can do. I think we can do further optimization. So let's not print this, and I was just being stupid over here. It's my problem. Okay. Okay. I am still printing all of this. Okay. Now, if I am evaluating all of these things, then at this point I am updating the sequence. Okay. But I should also update everything else. So for example, for S in sequence, if S is not in wait a sec. Yeah. I am enumerate if S is not in, if it is not there, you need to insert that as well. So S equals sequence I onward. So we insert everything else that we have just calculated. If S, okay, so when we are calculating 13, we enter everything else into the sequence, so we don't have to calculate all of these things ever again. Okay. Okay, so we start with this and we do that, but what we get back is the sequence, and we get back the previous sequence, and we provided the previous sequence. Okay, and if we do that, we want to print I, we want to print n equals the length of the sequence, and we also want to print the sequence, and it should give us the same number. So if we are at 13, it should give us 13, so it should give us 10 as the length of the sequence, and it should be able to give us all of this stuff. And if we look at previous sequence now, you see that it has already calculated all of these things. Wait. Why doesn't it have 40? Something is not correct. This seems okay. If we start with the previous sequence of that, give us everything, and previous sequence should have a much larger number of values. This is the problem. Oh no, this should not be the problem. Okay, so let's say I have this and equals that. So let's say I do that. If I ask myself what previous sequence is, it is that, which is correct. Now if I go ahead and ask myself what is previous sequence, what is this, if I pass in one more time, it gives me the same exact result. But now if I go ahead and say 40 is added to the list, okay, like it should be. It has the previous 13. Now what happens if I try to find 2? We already have 2. What happens if I pass 7, for example, 7? Something is not correct. Okay, so let me also print okay, so let me do this first and do that. So the keys are 2 and 1. When I add 3, I add 2 and 1 and 3. But I 2 and 1 and 3 and 4, but I don't add any of this. Why is that? Maybe this is not the right thing to do. Right. Okay, so and we break over here. This still works. Okay, this looks more more meaningful. And at this point we have all of these things. And if you look at previous sequence, we have 44, we have 88, we have 29, we have 58, we have 19, 18, 80, 160, 106. All right, so this is what we want. Okay, so let's we will do this. We will do 1000. Okay, we will not print every step. Okay, we'll say max length is 0, and if n is greater than max length, then we say max length equals n with starting number. Okay, max length is n, and we print I as the starting number, and we print the max length. All right, and we see that the value 179 has a max length of 871. Okay, wait, the value, this 871 has a max length of 179. Okay, so we need to continue this for 1 million. One, two, three. Okay, and okay, we are still calculating. Let's stop, and we will say from TQDM import TQDM. We put a TQDM over here like that, and TQDM, I believe it's called TQDM dot right, and we need to generate an F string over here, F, like that, and like that, like that, and 60. Okay, let's look at that. Would be the number for which we have the longest sequence. Okay, another problem solved. So we will stop over here, and we will continue again next time.